Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Incredibly Fast Object in Revealing Hi1a Images Likely Larger than the Sun. Now, the stereo Hi1a images below come from a Planet X News live stream from October 28, 2018. And a very large object can be seen in the images. You can see here. The object was labeled as Jupiter in normal Hi1a images, but in these images it is clear that it is not Jupiter. And you may look at article 424 entitled Large Planet X Object and Large Debris Field May Endanger Earth. The stereo Hi1a images allow depth perception and the view of details that are not usually possible from normal stereo images. And in this article, I'm going to use these images to estimate the object's size. And you can see the object in these two images. This one is from January 10, 2013, this one from 12. You can see that the object clearly decreased in size between the two images. And I estimated that it decreased in size by at least 1/5, which is 0.2. And so it moved by 1/5 of the distance that it was initially from the detector on January 10, 2013. So on January 12th, it was also impacted by large amounts of coronal plasma from the sun, as you can see here. And so that suggested that it was getting close to the sun, and the sun was reacting to its presence. Then here we see it again on January 12th, and this image is from January 14th. The object didn't decrease in size further between the two images. So that suggested to me that it had reached the sun and was now just moving tangentially towards the sun. And as you can see, it became completely immersed in coronal plasma, which the sun was ejecting furiously, obviously reacting to the object's presence. So the fact that the object did not seem to move any further from the camera between the 12th and the 14th, and that it became immersed in large amounts of coronal plasma ejected by the sun, suggests that the object reached a position which was at about the same distance from the detector that the sun is on the 12th of January. And we can thus do a size comparison with the sun to estimate its size. And this illustrates what I see the object's trajectory being. Of course, it would be a curved trajectory, but here I drew it as a straight line just to illustrate that it seemed to move in this direction towards the sun. Of course, there's stereo A. Stereo A was looking over here at Jupiter, so it must have crossed into stereo A's field of vision somewhere here, and then it moved towards the sun, and then on the 12th it reached a position where it just moved in towards the sun. So it stayed at about the same position that the sun is from the stereo A spacecraft at Earth's orbit. So the sun size can be deduced by placing Hi1 and Core 2 images together, like I have done here. These are from 2007. And just aligning the jets from the sun and the CME that you see here, and getting the size right of the Core 2 image so that they align, means that we can get an idea of what the sun would look like if it was seen in these images and what its size is, because it's indicated by this white circle on the occulter in Core 2 images. And you can see the sun would be very small indeed in an image like this. And it's done here with two 2011 images, an Hi1 image and a chord 2 image. And you can see that if the sun was seen in these images, it would be about this size. It's about the same as that. And then once we know that, we can put these Hi1 images together with this image, and we can get an idea of what the sun's size is. Of course, this is just a rough estimate, but even in this rough estimate, we can see that this object here is much larger than the sun, something like twice as large. And so this object is most certainly larger than the sun. Now, these objects are old spent stars. The debris field around them is the material that they have shed. They seem to share their own outer layers, most likely because they lose gravitational influence over their own matter when they become depleted in energy and electrons. They are thus low gravitational influence objects, but they are huge absorbers of energy and of coronal plasma from the sun. And you may look at article 210 entitled Stellar Core Gravity, Tidal and G is Not Constant, and article 418 entitled Planet X Dust, Replacing the Sun's Corona and Earth's Atmosphere. And here you see one of the smallest of these objects that come to the sun, and these small objects are observed making these gravitational vortex connections, which form due to the tidal force that these objects are able to exert on the surface of the sun. The larger objects, larger than the sun, have not been observed making these vortex connections with the sun, but seem to instead elicit a response from the sun, most likely due to the electrostatic interaction, as the objects will be depleted in electrons and thus strongly positively charged. This positive charge will cause the sun's outer negative layer, the corona, to react and discharge in the direction of these objects. The objects will thus be able to recharge by absorbing the sun's electrons. And you may look at article 412 entitled Planet X is Here, where I explain that. Now, the objects seem to reach the detector's distance to the sun, 1 AU, on January 12, 2013, when it seemed to be 1/5 less in size. Thus, the object moved a distance of 0.20 AU in 2 days. So its speed was about 174 kilometers per second, which is about 108 miles per second. So this object was therefore moving extremely fast. According to Newton's universal law of gravitation, an object orbiting the sun would be moving at that speed only when it is at a distance of 0.03 AU away from the sun, so very close to the sun. These objects do not seem to obey gravitational law, but the comparison serves as an indication of how fast the object was traveling. So in conclusion, an object estimated to be twice as large as the sun was observed approaching the sun between January 10th and January 14th, 2013. The object seemed to cover 0.2 AU in 2 days and was thus moving at about 174 kilometers per second, an incredible speed. And these are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.